Hello, welcome to Advanced Algebra 2. Today we begin the fourth learning target, which is about performing arithmetic operations, or if you prefer, arithmetic operations with complex numbers. It's a lot of working with going to happen here in this learning target, and we're going to begin with adding and subtracting, and I can guarantee you that adding and subtracting will be a thoroughly underwhelming experience. So let's get started. Hey, first example, we have to simplify 2 plus 3i plus 5 minus 6i. So to add them together, you're going to actually add the real numbers together and then add the imaginary numbers together. So we have 7 minus 3i. And then to make it look like this was actually work, I'm going to just rewrite it all in the same color for you. And then boom, 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 we're done. All right, second example, we have 2 plus 3i minus 5 minus 6i. See, we had adding, now we have subtracting, that's right. So we're going to subtract the real numbers. 2 minus 5 is negative 3. And then subtracting the imaginary numbers is next. Do pay attention just slightly enough to notice that it's 3i minus negative 6i. So that 3 minus negative 6, it's really positive 9, so positive 9i. So negative 3 plus 9i, and then boom, 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 done. Okay, adding and subtracting. Good times. Now, multiplying, this is where the fun actually begins. It really catches up with us later, but for now, we're going to start to have fun. So we got 2 plus 3i times 5 minus 6i. So it's a bunch of stuff that needs to get multiplied together. In fact, this is a case for FOIL. We got 2 times 5 is 10. You got 2 times negative 6i is negative 12i. You got 3i times 5, that's 15i. And then 3i, and pay attention to this last one, 3i times negative 6i is negative 18i squared. Woo, I squared. So before we keep going here, I want to remind you about something super cool. I is the square root of negative 1. And because of that, I squared is in fact just negative 1. Super duper awesome dream space sequence over on the right there in green. You need to know that. It's not very hard. Certainly not as hard as completing the squared. Oh wait, that's what we just did. Yeah. Okay. Anyway, moving on. So we FOILed it out. And so then if we just kind of collect some stuff here, we got 10. And then that's really 3i, right? Because it's like negative 12i and 15i. And then this is negative 18 times negative 1 because I squared is negative 1. So really, we're talking about 10 plus 3i plus 18, or rather, 28 plus 3i. And then, boom, we're done with multiplying. This, you can see there's something to do here. It's not super duper exciting. It's kind of like foiling x's and numbers and stuff in Algebra 1. It's just a little extra trick about I squared. All right. We'll do another one just for super duper kicks here. We got 1 minus 7i times 2i. And here it's not actually foiling because there aren't enough things to foil. But the 1 multiplies by the 2i to make 2i. And the negative 7i multiplies by the 2i to make negative 14i squared. But of course, I squared is really negative 1. And so we're really talking about 2i plus 14. All right, now, one bit about kind of notation here. You want to write the real part first, so even if you get turned around, you want to rewrite that as like 14 plus 2i. Just the 14 in front, 2i on the end, you're done. Okay, multiplying. So we've added, we've subtracted, we've multiplied. Man, we're feeling good about this. Just one left, but actually stop, wait, detour. Complex conjugate. Now, the conjugate is a cool thing because it's like if you start with a complex number, and here I wrote z because math people like to say complex numbers are z. Don't worry about it. It's like something plus something I. Then the conjugate is something, the same something minus that same other something I. So, and then we've got lots of examples, not because it's hard, but in fact because it's immediate, but you just need the visual. So, example 5, the conjugate of 2 plus 3i is 2 minus 3i. Boom, done. Just like it said above, plus minus. The conjugate of 5 minus 6i is 5 plus 6i. Boom, done. There isn't really work here. You're just like, oh, boom, boom. Okay. Now, example 7. Write the conjugate of 7. This looks like it should be less work, and once you understand what I'm after, it might very well be less work for you, but for the first time, I'm going to break it down a little bit. So 7 is really 7 plus 0y. Yeah, it is though, right? Because it's like it was 7 and now it's 0 y's. And you can't really complain that I added no y's because there weren't any to begin with. But the conjugate then, so I wrote 7 bar for conjugate, see what I did with the notation, is 7 minus 0y. So instead of having nothing added, I had nothing subtracted. Or in fact, instead of having nothing imaginary added, I had nothing imaginary. My head hurts. Look, if your number is real, the conjugate is the same number. That's going to be a big deal later, but like later is April. So, don't stress it too much. But, if you have a number, its conjugate is the same thing. Hey, kind of cool. Okay, example 8, the conjugate of 8i. Now, 8i is 0 plus 8i. Got to put the real part first, the imaginary part the second. So then its conjugate is 0 minus 8i. Oh, so its conjugate's just negative 8i. So if the number is just straight imaginary with no real part, its conjugate is the opposite. Whereas, in example 7, if the number itself is real but no imaginary part, its conjugate is the same thing. So you can either kind of just know the process, or you can memorize the rules. Either way, you're good. It's not super duper hard, but maybe you can tell me I'm wrong about all that in class. Okay. The conjugate is super magical, but first we need just a little bit of practice with it. So we're going to do the product of 2 plus 3i and its conjugate. So we're going to multiply 2 plus 3i times its conjugate. So times 2 minus 3i. 2 plus 3i times 2. Those are conjugates. Multiplied together. Product. Okay. FOIL time. 2 times 2 is 4. 2 times negative 3i is negative 6i. And then on the 3i, so we got 6i, and we got minus 9i squared. So, all FOIL. Okay. And then, we got 4, because 4. And then, no i's. Oh, well, okay. Whoa. Oh, yeah, because like 9, so like I squared was negative 1, so minus 9 I squared is like minus 9, but really negative 1 times 9, so it's really plus 9, right? Turns the sign around on you when you have I squared, but no i's anymore left. Cool. Okay, so then you're talking about 13, and you could write plus 0i, but no, please don't, because I'm trying to point something out, which is when you multiply a number by the conjugate, you get a real number answer. Okay, that's pretty awesome. That leads us to dividing. Now, dividing is actually where all the work is, so you'll quite likely write down more during these next 2 examples than all of the prior 9 combined. That sounds threatening, but when you see how simple some of the earlier ones were, it's not as bad as you think it is. Okay, here we go. So we got 2 plus 3i, and it needs to be divided by 5 minus 6i. Okay, well, I'm just going to write it down. Now, the trick is this. You're used to reducing fractions by dividing top and bottom by a number. One of the funny tricks in Algebra 2 is we're going to actually sometimes multiply the top and bottom of a fraction by the same number, just for fun, in fact, to help us out. So 5 minus 6i is your clue that you want to multiply top and bottom by 5 plus 6i. We're going to multiply by the conjugate. I guess we did that before in Algebra 1. Well, I wasn't with most of you in Algebra 1, but to remove radicals or square roots from the denominator, same basic idea, but it's not the exact same thing as what you see this time. It's the conjugate of the denominator. Okay, I've said too much. Let's go. So, up top, we have 10, and we have 12i, and then 15i, and 18i squared. Now, I just FOILed out the numerator. Let's see here. We didn't really have parentheses written in the old numerator, but they're really there. So I'll write them in now to show you that they're really there, even though, they weren't visible. Okay. For the denominator, we got 25, and then we got like a 30i, and a negative 30i, and a negative 36i squared. Again, just FOILed out those denominators. Okay. So, up top, we got 10, and then there's like a 27i happening, and then minus 18. So remember, I squared is negative 1, so instead of adding 18, we are now subtracting 18. That takes a little while to get used to, but I think you'll make it. Okay, in the denominator, we got 25, and then, whoa, the i's are gone. Oh yeah, of course, because it was the conjugate. Okay, and then I squared made it pause. It was -1, but then since it's negative 36, it was plus. So it's 25 plus 36 for the entire denominator now. All right, so we're talking about, let's see, 10 minus 18 is -8. So we have -8 plus 27i up top. The denominator is just now 61. It's entirely uninteresting. And then one last trick, just about format and notation, is that you want to separate it and write as separate numbers. So -8 over 61 plus 27 over 61, pause, wait for it, yes, and then the I on the side. Just that A plus BI form thing, and we'll mention that in class. Anyway, that's it for that one. I said that's it, but a relatively complex set of things to accomplish. Okay, one more, because this is not super simple. All right, so we have 7 plus 8i over square root 5i, okay? So we need to multiply top and bottom by the conjugate, and in this case, that's just negative square root 5i. Remember, if you're not feeling that, think about like how it was 0 plus square root 5i, and so for the conjugate, it's 0 minus square root 5i. Now it's multiply time. See, up top we have a -7 root 5i, and then we have -8 root 5i squared, because the I times the I. Okay, the denominator, we have just -5i squared, because the square roots went away, because the square root 5 times square root 5 is 5. That's the point of square roots. Okay, and then I times I is I squared. Let's have fun. Okay, we got -7 root 5i, and up top it's just plus 8 root 5. No i's, because remember I squared is -1, which changes the sign, so it's plus instead of minus. Yeah, you can do it. And in the denominator, we're just talking about a positive 5. Of course, writing the plus, not necessary, and, I'd say it's kind of gauche, but that's actually French, picking on lefties, like me, in fact, or other people. So, I won't call it gauche. But the denominator is just 5. I wrote the plus just to emphasize that it's a positive 5. Okay, and so we have 8 root 5 over 5, keeping it real first, as you kids would say, then minus 7 root 5 over 5i, and I know you kids don't actually say keeping it real. That's kind of a thing your parents say. Anyway, that's it for example 11. That's it for the whole notes, and we're done. So thank you. And please let me know if you have any questions.